Welcome to G Fun Facts Online. Did you know that your favorite pop star might be an earthquake hazard? Not in a metaphorical, shook the world kind of way, but a literal ground-shaking, seismometer-triggering kind of way. An entirely new category of seismic event, called a concert tremor, is taking the world of geophysics by storm. And it's not caused by tectonic plates or volcanic eruptions, but by tens of thousands of fans dancing in unison. This isn't just a quirky headline. It's a revolutionary new data source that's helping scientists understand the ground beneath our feet, test the safety of giant stadiums, and even map the hidden geology under our cities. Today, we're diving into the unlikely rock stars of earthquake science, from Taylor Swift to the Foo Fighters, and exploring how their concerts are creating a seismic symphony. Seismology, the study of earthquakes, has traditionally focused on natural events. But a new form of human-induced seismicity is on the rise, generated by the rhythmic, collective movement of massive crowds. The science is surprisingly simple. When you get 50,000, 70,000, or even 100,000 people jumping and dancing to the same beat, they exert a massive, rhythmic force on the ground. This creates seismic waves that ripple outwards from the stadium, much like dropping a stone in a pond. These waves are usually low magnitude, but they're easily detectable by sensitive instruments called seismometers, sometimes miles away. Now, you might be wondering what the difference is between a concert tremor and a real earthquake. A natural earthquake releases a sudden, sharp burst of energy that lasts for just a few seconds. A concert tremor, on the other hand, is a more sustained, harmonic vibration. It can last for the entire duration of a song, several minutes at a time. Seismologists compare it to the difference between a firework explosion and the continuous roar of a jet engine. The initial impact is different, but the total energy released can be surprisingly comparable. One of the first questions scientists had was, what's actually causing the shaking? Is it the massive, thumping sound systems or the fans themselves? Researchers from the California Institute of Technology, or Caltech, decided to find out. During a Taylor Swift concert in Los Angeles, they ran an experiment. They set up a powerful PA system right next to a seismometer and blasted music. The result? Nothing. It didn't produce the characteristic harmonic signals they were seeing during the show. Then, a single person started jumping next to the sensor, and instantly, the tremor-like vibrations appeared. This was the smoking gun. It definitively proved that the engine driving these seismic events is the collective foot-stomping and dancing of tens of thousands of fans. This field was recently thrust into the global spotlight, largely thanks to the enormous and incredibly synchronized fan base of Taylor Swift. Her Eras tour has become a seismic phenomenon. In July 2023, during a two-night stop at Seattle's Lumen Field, seismologist Jackie Kaplan-Auerbach detected seismic activity equivalent to a magnitude 2.3 earthquake. The event was immediately dubbed the Swift Quake. The shaking was twice as strong as the infamous 2011 Beast Quake, which was caused by Seattle Seahawks fans celebrating a touchdown. A month later, an even more detailed study at SoFi Stadium in California used a network of sensors inside and outside the venue. Researchers from Caltech and UCLA were able to identify the seismic signature of 43 of the 45 songs Swift performed. The song that generated the most energy? Shake It Off, which registered the equivalent of a magnitude 0.85 earthquake. But Taylor Swift is far from the only artist making the ground move. The phenomenon crosses all genres. The rapper Travis Scott's high-energy shows are notorious for it. A 2023 concert in Rome's ancient Circus Maximus, with 60,000 fans, generated tremors equal to a magnitude 1.3 earthquake, sparking a debate among Italian officials about the safety of hosting such events at fragile historical sites. Rock legends the Foo Fighters have been shaking the ground for years. A 2011 concert in Auckland, New Zealand, with 50,000 fans, produced what local geoscientists called a volcanic tremor. with the ground shaking steadily 3 times per second. Even country music gets in on the action. A 2022 Garth Brooks concert at Louisiana State University's Tiger Stadium with over 102,000 fans registered as a small earthquake on a campus seismograph during his hit song Callin' Baton Rouge. The event was affectionately nicknamed the Garthquake. But here's a fascinating twist. Not all high-energy shows produce the same effect. A study at SoFi Stadium compared a Metallica concert to Taylor Swift's and found that the heavy metal legends generated much weaker signals. Researchers believe this comes down to crowd behavior. Swift's fans tend to jump and dance in a highly synchronized way. Metallica's fans, on the other hand, are more likely to headbang, which doesn't create the same unified ground-shaking force. It's the synchronized movement that's key. So how do scientists actually study these tremors? Their main tool is the seismometer, a device that detects and records ground motion. For concert studies, they often use a combination of permanent seismic stations and temporary portable sensors called accelerographs. These are designed to measure acceleration and are crucial for understanding how structures like stadiums respond to shaking. In the SoFi Stadium study, researchers even used inexpensive, custom-built sensors, showing that this research can be done with accessible technology. Once the data is collected, it's analyzed with specialized software. A key program is an open-source Python toolbox called OBSPy, which is designed specifically for processing seismic signals. It allows scientists to filter out the background noise of the city, like traffic and construction, and isolate the concert signal. They then create visual representations of the data called spectrograms. A spectrogram is like a seismic fingerprint for a song. It's a graph that shows the intensity of different frequencies over time. Using these, scientists can see the exact start and end of each song, identify its tempo from the dominant frequency, and calculate the total energy it released. This is how they knew Shake It Off was the biggest shaker. While a swift quake is a fun curiosity, the real value here is in the scientific applications. This emerging field has the potential to seriously advance our understanding of earthquakes and improve city safety. One of the most exciting prospects is using these concert tremors to map the subsurface of our cities. Think of it like a medical ultrasound for the ground. The seismic waves from the concert travel down into the earth, and their characteristics change depending on the materials they pass through, different types of rock, soil, or sediment. By studying how these waves are reflected and bent, scientists can create a map of the local geology. This could help identify hidden earthquake faults, map out sedimentary basins which are known to amplify shaking, and better inform building codes in earthquake-prone areas. Concerts also provide a unique stress test for the massive stadiums themselves. The sustained, rhythmic vibrations from a dancing crowd shake the entire structure. By placing sensors all over the stadium, engineers can measure how different parts of the building move and resonate. This data creates a health baseline. As Monica Kohler, a research professor at Caltech, explains, you need to know how the structure responds when it's in good health to be able to detect changes after a real earthquake that might indicate damage or degradation. This allows for proactive maintenance to ensure the venue remains safe for decades. And perhaps the most immediate benefit is how this topic gets the public excited about science. The intersection of pop culture and geophysics is a powerful story. Seismologist Jackie Kaplan Auerbach was flooded with data and enthusiastic messages from Taylor Swift fans after her research went viral. This enthusiasm can be harnessed for citizen science projects, where fans contribute their own videos and observations to be correlated with the seismic data. It makes science relatable and can inspire a new generation of geophysicists. Of course, this noisy science has its challenges. Cities are full of vibrations, and filtering out a concert-specific signal from the cacophony of traffic and construction is a complex task. Researchers also have to account for the unique geology of each location. The ground in Seattle, for example, is built on soft, sedimentary deposits that are known to amplify shaking. which likely contributed to the strength of the swift quake. Looking ahead, seismologists are excited to collect more data from a wider variety of concerts, genres, and venues. They want to build a comprehensive model of how different types of human activity interact with the solid Earth. This research is a powerful reminder that scientific discovery can pop up in the most unexpected places. As Caltech researcher Gabrielle Tepp said, studying these non-earthquake signals helps seismologists reevaluate their assumptions and sharpen their tools. So the next time you find yourself at a sold-out stadium show, surrounded by thousands of fans, dancing to the beat, remember, you're not just part of a concert. You're part of a groundbreaking scientific experiment. Your dance moves are, quite literally, making the world a more understood place. Thanks for listening to G Fun Facts Online.